And we are off again. So, notes for 4.2. We are going to be working with polynomials, adding, subtracting, and multiplying, and finding some cool shortcuts for multiplying. So starting off again, what is a polynomial? It's basically a bunch of, so poly means many, so it is multiple monomials, you know, like the monorail in Disneyland, so one term, multiple monomial terms added and subtracted together. So each term is separated by addition or subtraction. So this first one is a monomial. There's no addition or subtraction. It only has one term. The second one, we see a negative here, subtraction. So we have two terms. That would be a binomial, like a bicycle has two wheels. Binomial has two terms. Trinomial then has three terms, each one separated by a plus or a minus. And the reason why it's helpful to know those terms is because if I say you're multiplying a binomial by a trinomial, what does it result in? You kind of know what we're talking about, all right? So adding and subtracting. The main goal here is be sure, first of all, to distribute the negative when subtracting. That's probably the biggest mistake people make, and I'll show you in the example how to possibly avoid that. And then basically to add or subtract, you are combining like terms. That is our goal. Okay, so adding is pretty easy. So what I'm going to do, we have an addition here in between these two terms. I like to line up my like terms. So 7x squared goes with the 2x squared. Negative x is going to go with the negative 6x and minus 9. And if I had something that didn't line up, it would either hang off to the side or not be combined in. So 7 plus 2, you're just adding the coefficients. You're not changing the variable. So negative 6 and a negative 1 is a negative 7. That's how many x's you have. And then 5 minus 9 is a negative 4. And that is your final solution. The ones that people tend to make mistakes on are the subtraction. So what I like to do is I like to turn this into an addition problem, which means we have to distribute that negative. So it's going to make this a negative, it's going to make this middle one a positive, and it's going to make this a negative. Now I can move them over here as addition. So I have minus 5x cubed is going to line up with the other cubed term, plus x squared is going to go here, and minus 17 is going to go underneath the minus 4. So I line up the like terms, and then just the coefficients is what you combine. So 3 minus 5 is a negative 2x cubed. 8 plus 1 is 9. The negative x has no one to join with, so it just comes down as negative x. And negative 4 minus 17 gives me my negative 21. And that would be your final answer. Okay? All right, now comes the fun part. We're going to be doing some foiling and distributive property, basically. So remember, first, outer, inner, last is just an organized way to do distribution, whether it's two binomials or a binomial and a trinomial. So there's also kind of some shortcuts that are nice if you can start to do this without having to do the whole FOIL, but let's just work it out in the beginning. So I have x times 2x, so that's going to be 2, and since I multiplied the x's, now it becomes 2x squared. X times 1 is a positive x. Now we're going to do the inner terms, negative 4 times 2x. Since that is a like term with this, I'm going to write it here, negative 8x. And then negative 4 times a negative 1 is a negative 4. Combining my OI, my inner and outer, I get 2x squared. 1 minus 8 is a negative 7x minus 4. All right. Now, if you're doing this next one is a binomial, two terms, times a trinomial, it's kind of like FOIL, but you're just going to have one extra term to bring in there. So we're still going to distribute the first term times all those others. So that's going to give me x cubed minus 2x squared minus 15x. And when I go to do this inner one, I'm going to line up all my like terms. So 2x squared is going to go under this term, and then negative 4x will go here, and the last one is minus 30. So if I have everything lined up, I can then just add downward. So I have x cubed, the 2x squared, they actually cancel each other out, minus 19x minus 30. And that would give you your answer. Okay, now you're going to learn some new, review some shortcuts that hopefully you already know, but also learn a new shortcut. So to start off with, we have the difference of squares. So if you remember your difference of squares, it would look like this: something squared minus something squared. It's a difference of two perfect squares. And to factor it, because you lost your middle term, you're taking the square root of the first term and the square root of the second term, and then there's a plus or minus in between. It's kind of like conjugates where they just differ by the plus and the minus. That's why you have no middle term. It got added and subtracted away. Then we have the square, a perfect square. So this is what you did when you completed the square. So it would look like let's look at it first here. A plus b squared. If you were to FOIL that out, you'd have a squared. You'd have the inner and the outer together would give you 2ab plus b squared. However, we could also have this as a minus b squared. That's also a perfect squared. In this case, it would be a squared minus 2ab, but still plus b squared. With those ones, I tend to FOIL anyway. I don't really recommend memorizing it. The difference of squares, that one happens often enough that it's nice to kind of just go straight to the shortcut. Now here's one that is completely new, the cube. So this one is when you have a cubed, oops, sorry about that. I did that backwards. So this is going to happen when we have a plus b cubed or a minus b cubed. And we want to come up with shortcuts. Now, I don't ever do this because I'm going to show you in the next page an easier way to do this. But if I saw it, it would look like this. A cubed, the first term, plus 3a squared b plus 3ab squared plus b cubed. And then if it was a minus, you start off the same, but then you have a negative in this first one, a positive in this one. Notice your a and your b's are the same. The only thing that's different is really the signs on every other term. Okay. Now this one also, I would not recommend memorizing that because I'm going to show you on the next page a really nice shortcut for doing these using Pascal's triangle. But let's look at how we would then apply these down here. So we have x minus 3 squared. Well, the reality is you're more than welcome to either use the shortcut or just first out or inner last. So it is going to give you x squared. The OI, negative 3x and negative 3x, gives you negative 6x, and your last term is negative 3 times negative 3. So that would be that one. Here, notice I have, this is a minus b, and this is a plus b. So rather than going through the whole FOIL routine, I know my answer is going to be a squared minus b squared. So I have 2x squared minus 5 squared, that's going to give me 4x squared minus 25. And now this last one, I'll go ahead and use our pattern, but again, I'm not going to emphasize that you memorize that, although you are going to be allowed notes on your the last test, I'll show you a way to do it even better in a second. So my first term is like my a. My a is 1 times x. So this is going to start off as x cubed, then minus 3 times a is, in this case, just x. So this will be x squared times 4. And then we have plus 3 times a, which is x, b squared, which is 4 squared, minus b cubed, so that's 4 cubed. Simplifying that gives me x cubed minus 12x squared plus, so 4 squared is 16 times 3, 48x, minus 4 cubed, which is 64. And that would be that answer. So it is nice to have a pattern, but again, I personally don't usually memorize that. I would do the Pascals, which we're going to do in a second. So here is Pascal's triangle. How do you create it? You start off with 1s on the outside, so then we split that 1. Then what you do is you're going to add everything that came before, but keeping 1s on the outside. So the 1s continue on the outside. 1 plus 1 is 2, which is where that 2 came from. So then we still have 1s on the outside. 1 plus 2 is 3. 1 plus 2 is 3. Next row, 1s on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, etc., etc. Pascal's triangle is amazing. There is so much in here. So notice we have 1s on this row. Notice in this row, you basically have your counting numbers, 1, 2, 3, 4, 5. These are going to be your triangular numbers. These are your quadrantal numbers. The powers of 11 are in here. The Fibonacci sequence is in there. There's a lot in Pascal's triangle. It's really amazing. How we are going to use it is each row actually represents, I don't know if you also remember combinations from probability. Each entry represents a particular combination. It also represents the coefficients of binomials, of when you're multiplying several binomials together and raising them to a different power. So for instance, a plus b to the 0. Well, anything to the 0 power is 1. Therefore, we have this 1 here. A plus b raised to the 1, well, that's just a plus b. So the coefficients on a and b are 1 and 1. That matches up with this 1 and 1. If we did a plus b squared, you get a squared plus 2ab plus 1b squared. Notice here are those coefficients, 1, 2, and 1. And we'll talk about how you get the powers of the a and the a, b, and the b. Notice here, each a and the b is 1 and 1. That adds up to 2. Each one of these exponents adds up to 2. If I'm cubing it, this is what we had on the previous page. Notice when you expand it, you have the 1, you have the 3, you have the 3, you have the 1. Voila, here it is in your Pascal's triangle. Notice that the sum of my exponents is always 3. So 3, 2 plus 1, 1 plus 2, 3. And if you just look at the A, notice it's 3, 2, 1, 0, and the B starts off 0, 1, 2, 3. So they go in ascending and descending order. And it keeps going. So without actually having to multiply these out, like a plus b times a plus b times a plus b, you can actually use the shortcut of Pascal's triangle and this pattern of the descending and ascending powers to quickly multiply something out. So a couple things to notice. The first and last number in each row is 1. That's the coefficient. So those are the ones on the outside. The number of terms that you will have are 1 more than the degree, which is helpful when you are mapping it out. So for instance, if I'm doing the 4th degree, notice I have 1, 2, 3, 4, 5 terms. So I have 1 more term than the degree that I'm doing. And yes, this allows us to expand higher powers very quickly. So notice here I have x plus 2 to the 5th. So to start off with, I know I'm going to have 6 terms. 1, 2, 3, 4, 5, 6. So I go to where I see the 5th degree. So that's going to correlate to what we have here. And I'm just going to first write down my coefficients, which are 1, 5, 10, 10, 5, and 1. Now we're going to start to expand. So we start with this first term, which is our x. And it's going to start off with x to the 5th, then x to the 4th. And we do it in descending order, x cubed, x squared, x to the 1. And just for emphasis, I'll write here x to the 0. We don't usually write that because that's going to be 1. Then I go to my plus 2. And since it is plus, I know everything here is going to be positive. We'll talk about when it's negative in the next one. And I do it backwards. So this now starts at 2 to the 5th, because that was our highest power, then 2 to the 4th, then 2 cubed, then 2 squared, 2 to the 1, and 2 to the 0. Notice that the exponents all add up to 5, so you set it up correctly. And now we put all our terms together and simplify. So this is just 1. So my first term is x to the 5th. Here I have 5 times 2. So that's going to be 10x to the 4th. Here I have, this is going to be 10 times 4. So that's going to give me 40x cubed. 2 cubed is 8. So that's going to give me 80. X squared. 2 to the 4th is 16. 16 times 5, I'm going to do that quickly, is 90. So this is 90x. Oops, did I do that wrong? That's 80, sorry. That's 80x. And then we have x to the 0 is just 1, so 2 to the 5th is 32. And you're done. That's actually, so x plus 2 times x plus 2 times x plus 2, 5 times, we were able to do it rather quickly without having to do foiling or any of that. So let me just kind of recap what we did. First thing I do is I map out the number of terms. So we decided, remember, there's always going to be one more term. Since it was 5th degree, we needed 6 terms. Next thing I do is I write my the Pascal's, the coefficients from Pascal's triangle. So that was the 1, 5, 10, 10, 5, 1. Then starting with A, or the first term, so you write in ascending, no, that one's going to be in descending order, descending powers. And then you start with the last term and descending powers, but I always start at the end and go forwards, going backwards. And then the last step is simplify everything. So combine all your like terms. All right, let's try one more. So this one is to the 4th power. So think about how many terms that means. So we're going to give ourselves a lot of room here because this one's going to have some simplifying. 1, 2, 3, 4. So we're going to have 5 terms we have to work with. So there's mapping out my terms. The coefficients, I now go to where row 4. Row 4 will be where you see the counting number 4. So that has a 1, a 4, a 6, a 4, and a 1. Plus you know you went to the right row because you have the right number of terms. So now we're going to start with, in parentheses, 2x to the 4th, 2x cubed, 2x squared, 2x to the 1, and I'm not going to write 2x to the 0 because that's just going to be 0. Now we go backwards. Negative 3. So I'm going to put it in as a negative 3. This is going to be to the 4th power. Negative 3 to the 3rd power. Negative 3 squared. Negative 3, 1. And then negative 3 to the 0. Okay, so now we have to simplify everything. So that means anything with an exponent in parentheses, that exponent distributes to both. So 2 to the 4 is 16, x to the 4th. Now this next one, notice that I have a negative in here. Whenever you have a negative, basically every other term, it's going to toggle between positive and negative. So you're going to have a negative, a positive, a negative, and a positive. So a negative raised to an odd power, that stays negative. But we still have to simplify. So I have here 4 times 2 cubed is 8 times 3. So we are going to probably want to have a calculator handy. And we have here 32 times 3 is going to give me 96. And then we have x cubed. So I like to write kind of my simplified numbers underneath and multiply them together. Next, negative 3 squared is a positive, so that's why this one becomes positive. So I have a 6, I have 2 squared, which is 4, and I have 3 squared, which is 9. So 24 times 9 is going to be 216, and this one gets x squared. Now I have a negative because negative 3 cubed is going to stay negative. So I have a 4, I have a 2, and 3 cubed is 27. So it turns out that 27 times 8 is also going to be 216, and this now is just to the x. And the negative 3 to the 4th is a positive 81. Now that may seem like a lot of work, but trust me, it's a lot shorter than going 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. It's kind of a really nice shortcut, and Pascal's triangle is amazing.